order, right? I don't go in order with these units, so that's okay. So trigonometry, encourage you to have a highlighter, right? And I will just give you a preview, right? In this little box, in this little section here, I will just say in grade 10 and 11, you used trig, and this SOHCAHTOA ring a bell. I don't know what your teachers, and not everybody uses SOHCAHTOA, but sine, cosine, and tan, right? You use trig to solve for sides / angles given a right triangle. So it's a bit small, I know, and that's why I'm reading it out as I'm writing it. But in grade 10 and 11, you use trig to solve for sides / angles given a right triangle. And a right triangle, you know it's a right triangle if you have a square in one of the corners. You have a 90-degree angle. Okay, so that's how you know it's a right triangle. That's going to change. Okay, we are not going to, a right triangle is going to be rare. Everybody has the booklet, right? I'm starting to teach, and I'm assuming everybody has it. That's going to be rare. Okay. In grade 12, let's do that. In grade 12, we will explore all types of triangles, right? So oblique triangle just means a non-right triangle. That's what oblique means. So if you're thinking of oblique, you're thinking of something like this, something like this, something like that. It just, there is no right angle anywhere. So we're going to look at so the right triangle is still there, but now we're going to also look at oblique triangles. Okay. I'm also wanted to add that make sure you bring your vehicle finance stuff with you still. Okay. From time to time, I will throw a little AC at you from those units, and it will be open book. So if you have your booklet with, you can always go back and see. Like if you're a note taker, you'll be fine. Okay. So the first one is sine law. I'm telling you already, there's going to be sine law and cosine law. That's it. There's no tangent law if you're waiting for that third. Sine law, cosine law allows us to solve for any type of triangle. Okay. So this is our first law that we're going to cover. I'm just going to peek here to see. Okay. Because I made a few changes here. Since we're working primarily with oblique triangles, okay, we will not be using the primary trig ratios you learned in previous years. That means that SOHCAHTOA, right, SOHCAHTOA will not work in most cases. So we just do not use them, okay? Don't use SOHCAHTOA like you used in the past, like you're going to be in trouble, okay? I think all I wanted to review here is, I think, working the Pythagorean theorem. But you know what? I will just leave that for now because it's going to be more relevant a little later. So for now, we just leave it like that. Flip to the next page. And this is just a bit of a review. Okay, prior knowledge, you should already know at this point. Sum of interior angles is always 180. I sometimes will just say this. Sum of triangle is equal to 180. Right? If you see me say that, then you'll be fine. Isosceles triangle is a triangle where two sides are the same and the angles across from them are the same as well. Okay. Equilateral is a triangle where all three sides are the same and all three angles are the same as well. And in this case, it's actually 60 degrees every time. It doesn't matter. The side lengths do not change it. It's 60 all the time. And then you have a right triangle where, of course, you have one of these. And let's draw one upside down because students think it always has to be. Different. Supplementary angles is two angles, right? Two or more angles that add up to 180 degrees. So let's do a couple of examples. So if you have a straight line, right? We know that if you pick a point on that line and you measure, these are two different vectors. Vectors is a fancy name for a line, right? This whole thing from this end to that end, if you measure the degrees, it would be 180 degrees. Okay. Always don't underestimate the power of a straight line, because sometimes you'll have something like this and you'll have a side cutting it like that and the point of intersection is right there. If this is 30, then you know that this is 150, right? So how did it, sorry, not 180, 150. How did I know that this is 150? I focused on the straight line here, right? A straight line right there tells you that the angles along, right, from here to here has to be 180. The sum will be 180. So if I cut it, then I have that. Let's do a slightly more complicated one. I have one going in there and one going like this, where our focus is going to be on this straight line here. So let's say I tell you this is 50 degrees and this is 30 degrees, right? So we know that the angle formed here is 30 degrees, this is 50. You should be able to tell, hey, 50 and 30 is 80, so this has to be 100, right? So in this case, you have three angles that are called supplementary, right? Those three angles add up to 180, right? Three angles add up to 180. Here you can say two angles. That's an angle symbol, by the way, this here. And it's just an S, right? So two angles add up to 180. So it doesn't necessarily only have to be two angles. Any combination of angles that add up to 180 are called supplementary. Got it? If I add them up and they add up to 180, it's supplementary. Notation, I need to make sure you understand that. Let's see here. Let's just draw a triangle here. And let's label the vertices or the angles A, B, C. Normally you go in clockwise rotation, but it doesn't have to be. A, B, and C. There are several ways of talking about, let's say you wanted to talk about this angle right here. Let's say you wanted to focus on that angle right there. Okay. I can call that, in this case, I can call that angle A. Or you can call this one angle, watch this. You put the A down and you go BAC. Angle BAC. It's the same thing, it's still talking about angle A. Or angle CAB. What? Say what? Yeah, so it's a three-letter notation for that same angle. Okay, so we'll say this. All talking about the same angle. Okay. And maybe I will just highlight the A on all of these notations. So obviously A is just standalone. There's the A there and there's the A there. Okay. Let's add another instance here. Let's make a straight line right here. And we're going to cut it right here. And watch this. We're going to put an A here at this point. That vertex there, right there, is called A. Let's put a bunch of dots at the end of each of these three lines that are formed. So we're going to go A, B, and we use capitals. A, B, C, D, like that. If you wanted to talk about this angle right here, what would you use? Would you be able to just say angle A in this case? Is angle A good enough? The answer is no, right? Because if you're referring to this angle right here, right, A is in the middle for sure, but you're going to have to call this angle B A C. Right? This angle right there, you would have to use the three-letter notation. Okay? Whereas if you wanted to use the other one, I'm going to use a red pen here for this other side. If you wanted to refer to this angle right here, and notice that the order doesn't matter as long as you have A in the middle of your notation, right? So this angle right here would be C A D. I forgot the angle notation like that. Right, so this, or Or DAC, that's okay. DAC, as long as A is in the middle of the three-letter notation. So then you're specific as to which one are we talking about. Okay. So that's that. Did you know this already? Or is this somewhat new? Somewhat new, it doesn't hurt to review, right? Because these are things I don't want you to really struggle with later on, because you're like, yeah, I've seen that before. Angle of elevation and depression. That one is a grade 11 concept. Okay? What I need you to remember is that there's always a horizon, there's always a horizontal line. So if you're thinking of angle of elevation, let's pretend there's this person here. I'm not good at art, so forgive me, right? And we're gonna make a horizontal line right here, a dashed line, right? Horizontal. So if that's our horizontal, then let's say we see a bird up here or a plane or whatever, something up, or you're looking up to a building or a tree. The line of sight from you to that object, that angle right there is the angle of elevation. That angle between the horizontal and the line looking up is the angle of elevation. So let's pretend the ground is here. If, let's say, there's a bug crawling, right? Right down there. If you look at the horizontal line and you're looking at the bug being right on the ground, that angle right there between the horizontal and the line of sight going down is the angle of depression. Okay, so if you remember that, you'll be fine. I think the key words right now, I'm going to leave that blank, and then later on as we go through it, I'm not even sure why I put that section there. It's new, but I'm guessing there are some keywords that are going to come up later that are going to help you. Okay. Yes, maybe this is what I would like here. If the question says, remember, if you have your compass rose, I think north, south is easy, right? East and west, that I need you to remember, because sometimes it's going to say so-and-so is due west of you or due south of you, right? So just remember that. So a tree is due east of you. How would you graph that? Well, this is the ground, this would be you, and the tree would be right here, right? East. It means it's right to the right of you, okay? So just remember, sometimes they will have questions like that. All right, let's dive into the math. Yeah, go ahead. Dive into the actual math here. And there's a lot of repetition here, right? What an oblique triangle is. But the first thing is we're going to deal with sine law here. Okay. Sine law using trig ratios, sine, cosine, tangent, as well as Pythagorean theorem can solve for missing side lengths of right triangles. But what happens if you know a missing measurement if you want to know something missing for an oblique triangle? right? What happens then? That's what we're going to discover today. So the sine law, right? You have to use an oblique triangle in certain situations. Okay. So here I'm going to add a few things. This is the formulas, right? I would add that to my study sheet for sure. And a note is, right, we only have one equal sign in our work, okay? Not that right now there's two, but I'm going to explain that in a little bit, okay? And I will make a note here. Go from capital A to lowercase a, and then go like basically from every angle, draw an arrow across like that. Okay. Note that each angle uses capitals, right? And the sides across them use lowercase, right? Angle A has side A across, etc. Right? So when it says note, just do one of those, okay? And I will also add this. I wanted to add that further up. I will just say the sine law also works with right triangles. I need you to know that, right? This is a big, some students think if they see a right triangle, they have to go back to SOHCAHTOA. No, this works with right and oblique, okay? So this basically solves the problem. If you somehow didn't get it in grade 10 and grade 11, this is your redemption, right? Like you get to experience it all over, okay? And I will add this. Remember that if you know two angles in a triangle, you can find the third by using sum of triangles equal to 180, right? Using that property. So for instance, let's say you're given one of these triangles, right? And you know that this is 25 and this is 35, right? And let's call this ABC. By the way, it's not always going to be ABC, but there you go. Angle A will be equal to 180. This is how you show the work, right? You have 180 degrees for all three. So let's just subtract 25 and subtract 35 from 180, and 25 and 35 is 60, right? So that means that angle A is going to be 120 degrees, right? Just as simple as that. A lot of students forget that, and I don't want that to happen. Okay? And watch this. This is probably gonna blow your mind on a Monday morning. This is gonna be the you won't be able to stop talking about it, right? So if this is 120, right? And if I come over here to this angle right there and I were to extend it like this, what would this angle be right here? If I take the base of this triangle and I extend it here, if this is 120, what's this going to be? 60, 60. Do we agree with a 60? Because right now you have a what? A straight line, which is always 180. So if you know 120, this is 60. So students, sometimes they get confused, like, wait a minute, you told me a straight line is 180 and the sum of triangle is 180? Yes. The sum of a triangle is 180 and a straight line is also 180. So it's kind of like, what, right? But that's it. This is true, right? So these two would be called supplementary, right? So we'll leave it at that, and then let's do some sine law goodness here. So we're on page 261. It says, using the sine law to calculate the length of side A. So side A is right here. This is right now my unknown. Okay. And soon we're going to talk about cosine law. So pay attention to this part. With sine law, if you have a pair, if you have an angle and the side across from it, if they're both known to you, you're going to circle it like that. And I want you to say known pair. Therefore, triangle, three dots like that stands for therefore, use sine law. You know you're going to use sine law in this case, because soon you're going to have to pick, right? So if you have a known pair, you're going to use sine law, right? Okay. Angle, side, pair, use sine law. Okay. So this is what we know about the sine law. And I always set it up this way, but you don't have to. Sine of 52 degrees, you can never just have degrees on its own. You always have to have it paired with sine or cosine. In this case, we're doing the sine law. So sine of 52 degrees over the side length, which is 16.8 centimeters, is equal to, notice that I have angles on top. So now I'm going to go sine of 72 degrees, and those could be decimals, right? The angles, so don't let that throw you off, over the unknown side, which is lowercase a. Right? So you set it up, right? Set up. Set it up like that. Angles and sides, right? And when you have this, we call that a proportion. You will cross multiply and you will divide. Just like before, but you need to show me the work. So you're going to go A is equal to I like to, let's go sine of 72 times 16.8 divided by sine of 52, just like that. And you have to be careful here with your calculator. Oh, why did I do that? A is equal to, we're going to figure that out. So grab your calculators and make sure you check first and foremost. If you don't have a calculator, you might want to grab one of mine to follow along. But yeah, you cannot not use your phone on your tests or ACs, right? So you gotta know that. Anybody else need one? Anybody else? Okay. See, football practice and math at the same time. Okay. Make sure your calculator is set to degrees. There should be a DEG or a D or something like that at the top of your screen. If not, you're not going to get the right answer. You're going to be frustrated, right? So you need to make sure you figure that out, okay? And so let's go ahead and type this in. I will tell you a secret, not really a secret, but a tip. I like to type in the 16.8 first, and then go times sine of 72. And you might have a backwards calculator where you first need to go sine of 72 and equals and then multiply. So this is what I get at the top. So for now, just because this is our first example, I'm just going to write down, I want you to use all the decimals, and then I'm going to divide this by sine of 52. So now I'm going to go divide sine of 52 degrees, and that side length is 20.28. And what are my side lengths in? They're in centimeters. So we put down centimeters and we circle that. That is our final answer. We've successfully solved for A. I will tell you what the common errors are. Common error. Calculator set to grad. You want to graduate, but you don't want that on your calculator, okay? That's, or rad. Hold on, yeah. It doesn't work. You don't get this answer. Okay. I'll come and see you. If you have calculator issues, let me know. I can help you, no problem. So the other one is forgetting sin next to degrees. So for example, some students do this. 52 over 16.8 is equal to 72 degrees over A. Right, that's wrong. That will not work for you. Okay? So those are the common errors. I'm just going to leave it at that. So I'm just going to put that on the side here. I want you to use, if you're not using all the decimals, I want you to use at least 4 as you're working, and then round final to 2, right? So you would technically get 1 mark for this part, the setup. This is work. You would get a mark there, and obviously a mark for your final answer for now. Once we do cosine as well, you actually get a mark for picking the right one as well. Okay. One more here. I'm going to extend. Calculate length of side B. Okay. Calculate the length of side B. Do it backwards, sort of. Sorry, I meant side C. Yeah, calculate the length of side C. Sorry, my bad. I'm figuring out the calculators here. Yeah. We'll do more. Connor, you had your choose? Okay. How you typed it in from? Oh, close the bracket. That's the problem. Go delete. There we go. Now try it. Oh, you gotta go times. Divided by sine of 52, and that should do it. Yeah. So good on you, Carl. Are we doing math or? Yeah. Okay. You should use that calculator. You should use a calculator. Well, you won't be able to use it on a test. You'll be in trouble. Okay. Calculate the length of side C. And so we have a bit of a problem here, right? As you can tell, we do have a pair, okay? We have a pair, so we know we're going to use sine law. I'm going back to the original. So use the pair always to get you started. Sine of 52 over 16.8, right? And then, now we have a problem, right? Sine, we're going to have to go sine of angle C over side C because you always have them across each other like that. Do you know what angle C is right from the diagram? What's that? 56. How did you figure that out? Right. So Gila used sum of triangles 180, right? So I want to emphasize that because a lot of students would be stuck at this point. I know 2 out of the 3, so I'm going to use sum of triangles equal to 180. So angle C is 180 minus 52 minus 72. And it's 56, you said? Okay. So angle C is 56 degrees. So that would be actually an extra mark on the side. Now I'm going to bring that back in here. So sine of 52 over 16.8. I can drop the centimeters, that's fine. I'm going to go sine of 56 over C. Now I have everything I need. So cross multiply and divide. C is equal to, I tend to put my number in front of the sine and then divide it by sine of 52. So let's see what we get. 16.8 times sine of 56 This is where having a calculator with 2 lines is going to be really helpful, right? The one that tells you what you're typing in. And 67. Make sure you add units. If you don't add units, right? Include units always. Right? Is it centimeters? Is it inches, feet, whatever? And make sure it's degrees as well. Okay? Right. So one more thing. There is a relationship between the side length and the angles. Okay? Remember, longest side will be across the largest angle. Make sure you know that, because if you do your math and it doesn't, you cannot check that out, you made a mistake. Shortest side will be across the smallest angle. Okay, this is a very good check here. So if we go back and label all of our sides, I'm just going to go up to the original. I'm just going to say this is 20.28, sorry, and the other one is 1767. And the angle C we figured out was 56, right? So let me go back here and just check. I'm going to look for the largest angle, which is this one, and check if it has the longest side across from it, and yes, it does, right? 20.28 is the longest side, and the shortest side has the smallest angle across from it, right? So you got, and obviously the one in the middle is the one that is left, right? So keep in mind that that's very important to double check. Don't just blindly trust your answers, okay? Let's take a little break here and I'm going to let you figure out I want you to do this here for 262. Calculate the length of, we're going to scratch the indicated sides, all sides. So all the missing sides I want you to solve. So you want to solve for one side on this side of the triangle and do the other one on the right side of the triangle. So you have 3 of them to try and see if you can do that based on what you've just seen and put it to the test, right? Pause it there.